Okay, 2.6, problem number 12. Now the directions are nice enough to tell you here that you're supposed to evaluate this one using the squeeze theorem, which is good because none of the other methods we've talked about would really work here at all. So to do the squeeze theorem, it's a three-step process, and the first step right here is always to take the trigonometric portion of this function and bound it, meaning kind of limit it between two values. So the trig portion, you're always going to be looking for the sine or the cosine, and you have to have the angle that goes along with it. So I'm going to start by writing the cosine of pi over x here in the middle, and no matter what the angle is, guys, the angle itself is actually irrelevant here. Cosine of an angle is always going to be bounded in between the values of -1 and +1. If you haven't figured this out yet, the only two trig ratios that the squeeze theorem works on are sine and cosine, and it's because of this reason right here. This would still be true if this were a sine instead of a cosine. Sine is also limited with a range of between -1 and +1, but it would not be a true statement if this were tangent, because the range of tangent isn't limited to anything actually. It's from -infinity to +infinity. And we have likewise infinite ranges with the three reciprocal trig ratios. So this only works with sine or cosine. Okay, so there's step one. Step two is going to be a little bit interesting in this problem. We need to take maybe just one step, but it could be 2 or 3 or 4, to try to manipulate the middle of this compound inequality right here to turn into the entire function we're trying to evaluate the limit of. So by following order of operations, the first thing happening to this cosine of pi over x is that it's being exponentiated. So we need to that's not a very good word right there, but okay, each of the three sides here. Okay, so what does that do for us? We now have e to the negative first, and we could rewrite that as 1 over e, should be less than or equal to e to the power now of the cosine of pi over x, and that in turn has to be less than or equal to e to the first power, which is just e. Okay, so that was step one of part 2 right here, but we also now have to multiply everything by the square root of x. So that's got to get multiplied here and here, and we'll put it here as well. So this should finish up step 3, and I tell you what, I think this first term I'm going to rewrite now as the square root of x, and we'll put that over e. I just think that's a little bit cleaner. That needs to be less than or equal to, and here we go, the square root of x multiplied by e to the power of the cosine of pi over x. That's messy, but okay, that's it, which in turn has to be less than or equal to e multiplied by the square root of x. Okay, so that was step 2. I know I'm done with that because the middle portion of this compound inequality now matches the original function here exactly, and that's what we were hoping to accomplish in step 2. Now, in step 3, this is the moment when everything comes together here, guys. The squeeze theorem only works if your lower limiting function right here and your upper limiting function right here have the same limit as x is approaching this value right here. Well, I think you can see pretty quickly that in either one of those cases, if we let x actually become 0, here we're going to get 0 over e, which is 0, and over here on the right, we're going to get e times 0, which is going to be 0 as well. So yeah, the lower limiting function on the left and the upper limiting function on the right have the same limit as x approaches 0, and therefore we can make this valid conclusion now about what's going on in the middle. Let me do a little wiggle right here, and I think I can make this a little prettier now. Okay, so we've got all of that. So let's go ahead, guys, and get the wording right. I always like to do it this way. We would say since the limit as x approaches 0 from the right of our lower limiting function, the square root of x over e, is equal to the limit as x approaches 0 from the right of our upper limiting function, which is e times the square root of x, and we have to go ahead and say what those limits are. They're both 0. So since the lower function and the upper function have the same limit, then we may conclude that the limit as x approaches 0 from the right of our function right here, which is the square root of x times e to the cosine of pi over x, that middle function there has to have the exact same limit as the other two, so our answer there is going to be 0. I think it's kind of unfortunate, guys, that so many of these problems that they give you here to work on just have the same limit of 0 over and over and over again. I wouldn't want you guys to start assuming that that is always going to be the case, but anywho, that's how problem number 12 works out. So in this case, we did end up with that answer of 0.